Hello and welcome to this video. In this tutorial we want to go one step further and perform a 3D manual metal arc welding simulation. In this tutorial you're going to learn how to create a 3D model which is different from the 2D model, obviously. We're going to perform thermometallurgical analysis of a manual metal arc welding. You're going to work on phase transformation analysis and post-processing the results, like exporting the curves and exporting the videos and do some cool stuff. The material we're going to study in this tutorial is 316L stainless steel, and in this slide you see the model's dimension. This is a material, a sheet material, a 5mm thick sheet material with the width of 30mm and the length of 60mm, but the welding is going to be on the transverse direction. So the coordinates of the model is presented in this slide. Is pretty useful while we're doing the simulation and we want to create a model. We should have a map of our model. I suggest you that you always write down these coordinates for you, whether you're going to simulate or regenerate some of the models from articles or some scientific papers. You should always have this map for you. And the material phases are presented here. The first phase is austenite, and while we're doing the simulation and thermal analysis, it's going to turn to ferrite, and the second phase, as always, is a filler material. So the heat source is the same. It's a goldite because we're going to do the manual metal arc welding, and everything else is pretty much the same. The major difference is the model creation. Alright guys, now we're going to create our model in Visual Mesh. So click OK. Here it is, the Visual Mesh. We click on New File and create our coordinates. As always, we go for node and create by XYZ locate. First coordinate is XY X0 Z0, which is the first one, and we're going to have the X60 Z0. We're going to create X60 and Z45, and we're going to have 27.5. We're going to have 33.5, and we're going to have 30.0. I think that's it, or we need one other coordinate. Let's switch back to this view. Yeah, we need X0 and Z5, and hit apply. So in the view section I already did uncheck the model coordinate system here, but you can have it if you want, so don't freak out if you don't see this one. Alright, it's pretty much our model. Let's double check. We have this one, 27, 33, 30, 60, and that's it. Alright, now we're going to create a 2D model with 3/4 point mesh, and let's do the weld first, and that's it. The element size, let's say 1, and see what happens. 1 is not good enough. Let's make this edge, let's set this as 10, and these two guys should be 9. Yep, that's good. So we keep this mesh, create mesh, and click OK. And then we're going to select our base metal section. There we go. So we're going to set this edge as 9, and we can set these two as 12. And let's do the biasing, linear bias and bias edge, this edge and this edge, and we're going to flip this one. I go faster right now because it's pretty much the same as the previous video. So I click OK. This looks good. Let's make this more visible, and here we have the other part. And mesh, we are going to do the same thing, 9 and 12, and this one for 9. Let's bias this edge and this edge, and flip the bias for this edge, create mesh, and here we go. So here is a 2D model we created, and it looks good. We don't need fine mesh here, so we coarse mesh is okay here because the heat is pretty much here, and when we have good size elements here, so it looks fine. Alright, so the difference between the 3D model and the 2D model, which starts from here, we're going to select the weld zone, hold and shift to unselect, and we can just click on the weld part to select this one, and we right click on the weld part, and we're going to add it to a new part, which is this one. Alright, now we're going to make this 2D model, let's turn this 2D model to a 3D model. So we should go to the 3D tab and select the sweep or drag. Alright, the idea of this sweep is to select some faces and sweep them into a direction or a vector which is in our favor. So I'm going to hide that part and only make the weld part visible, and the first thing to do is to select the element faces. So we are selecting our elements, and we can click here to update faces. Now the faces are updated. From this part we're going to select a vector. I'm going to select the standard axis because we're going, right now we are in ZX direction, and we are going to sweep this material and extend this material into the Y direction. So I select standard axis, and I'm going to select the Y axis as well, and this should be global. And if we rotate the model by holding A. So by holding this A, you can create we can rotate the model and see here is the vector we are going to sweep or drag our model into. So this is in the direction we want. If you want to do the other direction, you can simply click on flip and that's it, but we want this to be in this direction, so we click OK, and the distance should be 30 because our model, the length of our model is 30 millimeters. So here you see is the expectation of the model, so this is going to be extended in this way, and we click on create mesh. Now we're going to select our seeds into this direction, so let's keep this one as 60. We can do the biasing, do everything else we want, but right now it's okay. We want 60 elements on this length, and if we click on mesh volume, we see our mesh is not created yet. We cannot see that actually, but you can kind of see whether is the model is in your favor or not. Or let's modify this. If we want it to be smaller, we can make this as, for instance, 90, and we see how our mesh is going to be. I think 60 is fine, so I'm going to keep this and click OK, and now our mesh is created. So as you see, this is a new part containing all of our new elements which are in 3D. So here we have the 2D face, and this is our new 3D model. So we're going to rename this one. I'm sorry. We right click and we go to the part manager and we rename this one as weld. Alright, so I'm going to make this part visible. We don't need the weld right now. Alright, I'm going to do the same thing in the 3D tab. I want to sweep and drag, and now I'm going to select the element faces. These faces are selected, everything else is in the correct order, so I'm going to click on mesh. I'm sorry, I have to select this element and have to update faces, then I click OK, and here we go. We can mesh. So that number was 60, and if we want it to be a correct mesh, it should be 60 as well. So we click OK, and the mesh is OK. Alright, we have a new part. We can rename this one as the left hand side. So we go to the part manager, we select this one as left. It's pretty useful if we want to do a dissimilar welding. We can assign different part, so we can assign different material, I'm sorry. So we're going to make this one invisible, and we're going to select 3D, sweep drag to do the other part. So I'm going to select this part, right hand side. update faces, you can select it either from here or here, and we click OK. Then it is created, and we say mesh and 60. Okay, now we have our new part. So this part should be renamed. So let's say right. Okay, right now we have 3 parts: left, right, and the weld. Simple as that. We can create a 3D model. So we don't need these 2 parts. So let me show you these parts. These parts are the 2D model. We can delete them, or we can keep them as they are. I rather not to delete them originally, because maybe our meshes are not good and we want to modify that, and we want to do the sweep and drag again, so we need these 2 parts. But I'm going to maybe hide them. Yep. Alright, so the next thing to do is to go to the checks and select the coincident nodes. As you see, we have thousands of nodes that are coinciding on each other. So we say coincide all and fuse all, then apply. Now we're going to check that again, and we see there are no coincidence node. So I click close this dialog, and the next step is to do the heat transfer. Do the heat transfer part. So in the previous video we went to 1D and we extracted the boundary of the heat transfer from the 2D mesh, but right now we should go to the 2D and we can extract from 3D mesh. Alright, here we have we can select our element faces. I'm going to select all of them, but here we have 2 options. We have one open faces and one all faces. I'm not going to select all faces because inside the bulk is going to be selected if I choose all faces. So this size of let me show you. If we see the weld inside, this size are not in contact with the environment, but if we select that, it's going to even select inside the weld, which is not correct. So we're going to leave it as open faces, selecting all of them, extract 2D, and this is selected, and we hit apply. Now as you see, we have a new part. If we unselect all of them, we see that these are the parts are selected, and are hollow inside. This inside the bulk and inside the weld is not selected. Alright, so I would like to put that on isometric view. Let's rename this part. From part manager we can rename this one as heat env, and it's okay. Alright, the last thing to do is to select the nodes required for the clamping condition. I'm going to rotate this one here to the back of the model, and from here I'm going to select the node, and I select this node and this node. We have to make sure that we selected the correct node. So the nodes are selected, and I'm going to right click anywhere, add to new collector. So we have a new collector here, and I want to rename this one. Sorry, from the edit we rename this one as UXYZ because it's going to be clamped, and we're going to apply a boundary condition on all direction. The next clamping condition we're going to choose is slightly different. We're going to first we click on anywhere on a screen to ensure that we haven't selected anything. Now we're going to select this node here and this node here. Yes, it is. And tool, add to new collector. This collector, we want to clamp this one on only Z and X direction, and we're going to select the last two, which is first we have to click on the screen to unselect all those nodes. We click on this one and this one. Right, two nodes are selected here. I'm going to right click, tools, add to new collector, and edit this one, and this is only clamped in Z direction. So that was pretty much everything. I'm going to making sure that I selected the right clamp condition. From view, I'm going to uncheck this model coordinate. This is the U XYZ, this one the U Z and X, and this one is the UZ. Alright, that's it. Now it's time to save our model. So we can either do the shortcut of Control S, or we can select it from file and save. So I'm going to save it on the folder here, SYSWELD, new folder, and let's say 3D MMAW, and here I'm going to select 3D MMAW. Now the model is saved. Now it's ready to go to the next part, which is the welding parameters. See you in next video.